Okay. So logical representation. And then we will do coding in Python. Some of you do not like coding. Raise your hand if you do not like coding. That's okay, but raise your hand. It doesn't mean that you are good or not, okay? Although you are not yet good, but still you may want to be a good coding expert. So last couple of days this is something that I am now telling you. The theory itself is very formal, but the real implementation is not really formal, but in Python. So from my experience in Python, from my experience in logical expression, they are well matching. And reasoning about the facts also implemented at my side. I don't think anyone has been doing that. So if you can follow, you may do so, but it's not really mandatory. But anything on slide, not much about the coding, should be understood by you, but coding is extra, okay? Those who want to do more intelligent in your future career, I strongly recommend you to do. Recent, I think the articles published yesterday, a news article. Hackers make their hacking program intelligent. So hacking program is also evolving, which means, you see, that is very, very interesting articles, right? So hackers are leading us. So if you avoid to follow high tech, then you may be immediately drifted away from mainstream, which I do not want you to be. Okay, so try to follow. So at the first spoon of feeding, I don't think you can be satisfied, or anyone else really excited at your work. But if you continue to the same work repeatedly, then eventually you may realize that, oh, I'm the only one, which means you are on the peak, okay, in any area. But real important thing is that don't stop. Stopping is really, 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 really bad. Failure is not really bad. Failing something, there is a step to succeed, right? So no one can succeed without failing. So failing is very, very natural, but stopping is really miserable. If you stop doing something that you believe that you are on the right track, and that is a part of the track that you want to achieve, then you cannot reach the goal. Okay, so I'm not going to say much about that once. But here, knowledge representation, so-called KR. Knowledge representation is a tool for data mining. Whatever you do mining, you need to have some tool. You need some representation, right? And one very typical representation is a numerical representation, right? Numbers on table. Then you can do some work, some arithmetic calculation, or any statistical tools that you may be able to apply. as far as there is something in number. What if something other than number? Statistical tools is not working, right? What about the images? When you see some image, and next time you see some related images, then you may get some, right? That is intelligence. How come you have that connection? Not only images, sound. When you watch movies without sound, sound is very, very important, right? Sound multiplies the effect of videos. Think about some horrible, scary movies. You see the scary movies? Like 13th Friday, from my mind. If you watch that with no sound, do you feel really that horror? No, nothing, right? That is just, somebody's makeup so ugly. But ugly makeup will become really, attacking you if there is some sound, right? Okay, so representation is important. So given the world, any world, okay, we need to express the general facts or beliefs using a language. So far, last couple of minutes, I try to explain some situation, some importance of knowledge representation using the cases of sound, images, video, numbers, or text, whatever, right? There's a knowledge representation, the one that I just explained, right? And that knowledge representation should determine what else we should believe, what else we should not. Think about this. I'm not sure what it is. Challenging to you. It's not really challenging. Think about that. What can you say about the scene above, images above, that one?
It's green on top of red, which is on top of blue.
Oh, you have something. What else?
There are two squares, one small one's green, the bigger one's blue, and there's a photo.
Okay. Who else? Something other than what they just explained? Okay. Well, somebody may think, oh, there is a gray big wall, and that shape is just open wall, open hole with some of the different lighting. How about that? There's another, right? How can you explain what you see to a computer? Can you explain that to a computer? We can speak so many others so many times, but how can you explain that? How can you express what you think or what you can express to a computer? As Anno said, the red block is above the blue block and green block is above the red block. Is it only? What about red block? No, blue block is underneath red block and so on and so forth. However you express. We know that. Once we know that, we know some relationship, right? Above, below, whatever, right? Touch or but language-wise, we are able to express very limited concept compared to full-scale expressiveness in our brain. We can think a lot more than that, right? But computer cannot. We cannot express everything that we think to the computer repeatedly. Thing is this: as we express there, as we expressed here, by expressing that minimum statements, this and that, we need to, if we are intelligent, we need to deduce or inference something more than that, right? This guy is talking about, for example, above. Then in reverse relationships, we may say below or underneath, under, whatever, right? Not only that, we have only the relationship in adjacent, right? Red, blue and red and green. By knowing adjacent relationships, we may inference further relationships, right? So the thing is this, efficiency issues. Should we express everything that we think to the computer? No, it is impossible, right? But we know which one is minimum. Somehow this guy is redundant. Only in the case that your computer is a little bit intelligent, right? By knowing that A is B and B is C, then we know that A is also C. What is the relationship called in mathematics or in logic or in your daily language? There's some terminologies. Huh? Huh? More than that. Yeah, finally it is equivalent. So relationship is trans, right? So transitive. So A implies B, B implies C, then A implies C, right? That type of things. So effective, efficient, and what about effective? If we express some fact effectively, so that with the minimum expression, it expressed real core fact, right? Another example. If it is a sunny today, then sun shines on the screen. Oh, sun shines on the screen. If sun shines on the screen, the blinds are brought down, the blinds are not down. So, if we know sunny today, then because it is sunny, and because we have that rule, we say this is a rule, for example, okay? Because we have some theorem, some rule, and because we have some fact, according to this fact and theorem, we may derive some fact, right? The fact that we know for sure is today is sunny, for example. But along this, we may deduce some more. Okay, this kind of reasoning tool is in the base of the data mining. Say we know big data, right? So big data is constructed from everywhere, about all, and at all the time. If we have a really, there's no complete big data. Therefore, there may be bigger data. If we have a bigger data, bigger weather data, then we probably forecast more accurately about the hurricane path of Irma. Have you watched the weather forecast 2 or 3 days before Irma really became strong? The newsman said, there is an American system and European system. According to the American system, the Irma hurricane will not go into Florida, but it may turn along the coast, like Atlantic coast. It goes up a little bit and then turn back to the deep Atlantic Ocean. European system tells us that it goes into the Gulf area, Mexican Gulf area. Both are wrong. If we say they are accurate, but both are very close. So Irma actually took the path in between. So Irma went up from the Key West and along the land of Florida Peninsula, right? But if we have bigger data than current weather forecast the system has, then might have a little more accurate path forecasting. Maybe next year we may have better weather forecast, and then following year more and more. So if you have a big data, then it'll be useful and meaningful. Let's assume that we have a big data. How can you use big data?
Emerging pattern or trend to predict the future.
You're going too far already. You graduates. Let's start from browsing. Okay, we have just big data. Then what you need to do? Just browse to see if there is anything that I am interested in, right? Or search. If you know what you want, then you search using whatever the pattern that you can express. One of naive approaches that using keyword, right? You can search using keyword that you want to achieve. That is also possible. Another way, as Jean. Is it your first name is Jean?
John.
John. Oh, this is John. Yeah, John Pierre. What? JP. Okay. As JP expressed, if there is some learned pattern outcome of data mining, then that is real valuable and useful and meaningful knowledge that you can optimistic expectation to the technology, then we may have that, right? But from the big data to that pattern, which is useful and meaningful, it's a big gap. So we need to develop some technologies in between. So, say, bytes of data. Petabytes is 1,000 times of terabytes, right? So big data. If they're all numbers, for example, if you want to read by your lips, it takes several years. But anyway, is there any meaningful fact? We call that learned fact. So, question is, how can computers do? So that give you some patterns that you think interesting, meaningful, useful, right? So mining is this. Given fact, we can generate new fact. That is mining. But if fact is in some repository, and then new fact derived from the existing fact, which is good, so you store that fact again back to the same repositories. So you have some circular mining process, then it is called learning. Okay, so that is a goal. Data mining is really still hot, but we need to think of one step further, which is so-called machine learning. 2 days ago, there is another article, but similar articles announced, I think, a year ago. You probably read that article. It says machine learning algorithm, machine learning, whatever learned by machine learning, is so racial and sexual discrimination. There is this very, very powerful machine learning algorithms available. Okay, let's assume that. So apply that machine learning algorithm to any big data. And finally, your machine learner is so racial, it's racist, and also sexual discrimination. Why? And then that article says why? Because that algorithm learned from existing documents. There are so many existing documents talking about racism, talking about sexual discriminations. Therefore, that machine learning learned it from existing document, existing fact, existing big data. So, algorithm itself, that's perfectly nicely run. right? It is okay. What is now problem? Fact is the problem. Fact to train that machine learning algorithm is the problem. So when you train some algorithms, the fact should be very, very carefully. It should. You need to make sample data for training with great care. Otherwise, carelessly generated sample data or training data affects machine learning techniques badly. Therefore, if some machine learning techniques becomes powerful and extensive, then as what is his name? Remember those two guys had different opinion about AI. Elon. As Elon says, there may be some skeptical consequence from artificial intelligence. Or, on the other hand, Mark Zuckerberg says, oh, there are a lot of things that we can take advantage of, right? So that may happen. As technology evolves and advances, there's always pros and cons, right? Think about nuclear bomb. Right? Einstein makes really good concept, but Manhattan Project implemented it to make a bomb. That happens all the time. So learning artificial intelligence should be very carefully managed. Scientists simply develop, right, at certain level. But users, there are two types of users. User with a good mind and users with the evil mind. All the time, right? Knowledge representation language should be expressive. Simple expression implies much. Okay? Unambiguous, ambiguous. That's of course, right? And also flexible. So we're talking about fact, the language that can describe about the fact. That should be expressive, unambiguous, and flexible. The inference engine itself, learning algorithm, mining algorithm, should be correct and complete and efficient. Complete is also very, very important. Some algorithm produce the partial. And if you put your trust on that outcome, then that is a partial reasoning. Efficient. Something, we have very, very powerful data mining tools, but in order to get a useful pattern, hey, wait a couple of weeks, then it's not good, right? Should be efficiently respond. Candidates for knowledge representation, of course, English. Natural language is a part of, simply that is the language. That is knowledge representation. As far as we have good inference engine, like natural language processing engine, then natural language is perfect language, and that is also powerful. There's a big community in data mining have been focusing on some development against natural languages, like text data mining from text database. If that works, then text will be anything. Like that data miner can do something from newspapers or some any text from textbook also. So part of the implementation successfully done in IBM. You know that, right? What is his name? Watson, right? Watson learned like millions of textbooks. Therefore, what is a textbook? That is the natural language, right? So learned something from that text language. Not only that, it reasons about that text language. So inference engine, that is the key part. That is what that Watson has. Another language may be Java, Python, simply programming language. There's a special knowledge representation language, like logical language, so-called Prolog. Prolog is a language used only late 1990s. So I learned a lot of Prolog when I was a young scientist, Prolog, but not anymore. There's a few teams developed the Prolog language in Python, but it's not really powerful. Prolog is not as powerful as Prolog language itself, so it's not really good. We can develop something simply in Python. Okay. Logic. So logic consists of two things. Language, so knowledge representation, right? Whatever the fact, language so that fact or big data can be expressed efficiently, effectively. And also inference procedures, inference engine, some algorithms, some implementation. So if you have a language and inference engine, then that language can express whatever big data that you have. That engine is running against that big data so that it produces some outcome. That is data mining and machine learning. We'll work on some of those. Okay, so we are ready to do a little bit of logic. Okay, logic. Propositional logic. Any letters can be a propositions, so we call that atomic propositions. Atomic proposition is a statement that does not specifically contain substatements. So that is an atom. Okay. No more to be decomposable. Okay, that is atomic. So example of atomic proposition is, it is raining. Okay. Another, Q is not really atomic, but it is propositions. Like neither did Jack eat nor did he drink. There's a combination of two atomic, right? And also negations. So Jack eats, Jack drink. So from there, that atomic expression, we negate it. So Jack did not eat, Jack did not drink. And after that, combine them. Right? So we have eat and drink, but there's a negation. Nor, neither. And nor is also connector. So and not, right? Or not. And or not. So connector and then negations. We call that compound propositions. So Q is a compound propositions and P is atomic propositions. We can further compound using OR operation. This is OR. P or Q. If we combine these two, then it will be either it raining or neither did Jack eat nor did he drink. Something like this. How to implement it in Python? For example, so we have to think. We have to start from proposition. What is a proposition? So proposition is a statements. So propositional statements consist of subject and predicates, and then there is a verb, right? Like is or is not. So if we express the previous statements, Jack did not drink or did not eat, then we can say subject and predicates. Name is Jack. Eat is none. Drink is none. That type of variable and value pair. We can express that way, right? In the previous slide, there is a statement, natural language statements, that can be expressed the simple way. Or we can consider on objects, like an objects. Those who understand object in object-oriented programming language, that is the object that I am talking about. In Python, you can also express on objects. So person can consist of Jack, false, and false, depending upon the class definition. Let's assume that class person is constituted over name, eat, and drink. Three components, three elements of person. Then a specific object is Jack, false, and false. So we can simply say Jack, no eating, no drinking. That is a representation. If you see here previous, this is a natural language statements, right? this statement is represented in this way. This or this. Number one approach is a simple, but among those variable and value pair expressions, no connection, right? But if we, the second approach, the object approach, then we can say, oh, they're all together, right? Jack, no eating, no drinking. That's what we can express. Another way is that we can express that in a table, like Excel file. Let's say this is a person table. Okay, so we have a column title, name, eat, and drink. And the value for name, Jack. Value for eat, false. Drink, false. Okay. So, simple statements can be represented in a language or in a repository like Excel file. So we know how to interpret it, and the system, computer, algorithms also should be implemented in the way that we interpret it, so that your computer should understand that. Not only that, some reasoning technique, some mining, learning algorithms should be also implemented. Therefore, altogether, your algorithm and knowledge representation together work to generate, to produce new fact, new pattern. So, it's not really atomic propositions, say proposition. If we have P and Q, P or Q, then P can be expressed in this way. If we have a weather objects, then weather comes here, and then we can say we bind rain. The variable T is rain. Therefore, according to this weather objects, say raining. Okay? D can be anything, right? Today or tomorrow, or the amount of raining, whatever that you want to express. Person. Similarly, person, we have a name, eat or drink, so that we can say this is an object, and then AND operator. Given this objects, and N equals Jack, and E equals false, and D equals false. So this itself is the expression of about the propositions in Python. Okay, there is a language in Python. You can express in this way, or this is one way, or you can express in this way. Where the object itself has that value. Value is bound. Person, objects has a bound value. Both are okay in logic. The first approach, so that this can be a variable. Some programming techniques. Okay. In this case, this is simply hard-coded value, but can be taken from user to fit in. So how can you do something from that knowledge representation? If we have propositions, then we can apply some connections, so connectives. Negation connector, say it is raining. The negation to that statement is it is not raining, right? It is snowing. It is not snowing, something like that. There's negation, conjunction and disjunction. So we have conjunction and disjunction. Conjunction is AND operator. In symbolic expression, we have this caret. And the disjunction, this operator. We call that disjunctor or conjunctor. So P conjunctor Q, which means AND operator. Disjunction is OR operator. Another one is exclusive OR. One or the other, right? That with the connections, we can express that way. And further, once we connect, and we can also negate it, right? We call that NAND operator or NOR operator. Implication. This is important. Implication. P implies Q, but not, which means not P or Q. They are the same. Identical. So that is a very, very useful tool to express. For example, if you know coding, so simply if coding, we can say coding implies high paid. Coding implies high paid. You don't need to code throughout entire life. But if you start with the coding positions, then you will, later when you become manager, director, you can manage everybody, right? If you do not know coding and become a director, then you know all of your subordinates, but somebody who can coding, because you do not know coding. So at your beginning stage, I know your goal is not, your utmost goal is not coding, but still, then you can be, you can do better function even if you are in the higher position. That's what I ask you to do. And also starting pay, speak the front, right? Same positions with coding or with no coding. Any positions. If you have cybersecurity positions with coding, then I think starting pay at least 150K. With the undergraduate. Because you have cybersecurity and coding. If you know coding itself, no. It's not really well salary. Whatever you study, coding or business or health, whatever, okay, engineering, but if you do coding together, then somebody else, say 50K, but with the coding, 80K, something like that. So you are in the right track. Cybersecurity, so you need to know cybersecurity issues and concerns and legitimacy, treatment, whatever, right? So you have to do two things together. Let's say let's assume this is a implication. Let's consider this. Okay, if coding high paid. Okay, that is the rule. Let's assume that is the rule. And then when you see employees in your company, let's say this is your company rule, okay? So your company comp rule. So when you see employees, your company, then there's two cases. Two cases of employees. High paid employee or no coding. Okay? Think about that. We assume now a company has the rule saying if coding, high paid. So apply that rule to all employments. So when you see employees, two types of employees, only two types. High paid employees or no coding. Is that true? But actually two things, right? Those who are able to code or no coding. If they are able to coding, they are already high paid. So only two types of employees. High paid employees or no coding. What does that mean? If we have this rule, coding implies high paid, this is the same as no coding. Or high paid. Right? as we looked at here, which means this. P implies Q means not P or Q. See, this is a not coding. Or high paid. They're the same, right? So some other combinations. You can take a look at that. So we'll get back to that in Python. So the thing is this. If you have a premises or antecedent, so all kinds of conditions, you have a condition 1, condition 2, condition 3, then you have a conclusion, which means P1 and P2 and whatever implies C, the general form. So from that general forms, we're talking about modus ponens. If we have a rule, this is a rule. Say P implies Q. And then there is a fact, P. Then your conclusion is Q. This is your conclusion. Which means, back here, if you have this rule, this is a company rule, right? Somebody comes in and apply for a position. So you can simply ask him, do you know how to code? If he say yes, then what? What are we going to say? Right. So he said the coding, yes. Then you simply jump to high paid. So your conclusion is high paid. Your answer is yes, coding. So conclusion is high paid. If you say no, then that rule is not applied. Right? Because condition is not satisfied, that rule is not executable. That's what modus ponens can do. Given a rule, if you have a fact that satisfies the conditions part, then you have a consequent, which is Q. So also known as the cut rule. Cut rule. Okay, modus tollens. There are some others also available, but we don't need to. We're talking about modus ponens only. So you can apply some other modus tollens, and there are a lot of other theorems developed in logics, not in computer science. You can implement that. But you can implement that modus ponens if you spend a couple of days. If you are the same skill as mine, then maybe 3 to 4 hours. I spent this afternoon and successfully applied that modus ponens, which is good, right? In Python. I'm going to give you a demo. So what happens here is that that modus ponens is that if we have a fact P, if we have a rule, this is a rule, right? Not P or Q is nothing but P implies Q, right? This is a rule. So you have a rule, you have a P, then your consequence is Q. are they correct? So it can be proved by truth table. But I think you've done this in other courses, right? What? Discrete structure? Somewhere there. So we don't need to do. This is simple. I think even high school they did it here, right? So what math subject covers this truth tables in high school? In high school.
Oh, calculus? No, trigonometry? I don't know. Quantitative doesn't ideal.
But in high school, there's some math subject covers this type of things, right?
Quantitative reasoning.
In high school? Oh, yeah, this is quantitative reasoning. I don't remember. Yeah, my son, when he was young, he asked me this when he was somewhere in high school. Sophomore, junior, I don't know. Okay, so we don't redo that. A lot of inference engine developed in Python. I'm introducing here. If you are interested, you can download it. But before you download it, you have to install Python, right? PYKE from that website. So KE means knowledge engineering. KE, knowledge engineering in Python. Know, something about knowledge. Or prologue, if you are interested in, but we are not going to do it here. Okay? Any question? By the way, so far. Okay. So, with that in mind, next issue, as I said the last time, first few weeks we do not have break. But for those who really need to break, you can freely, individually, can do. Any missing parts can catch up, because I am recording this and will be posted on your Blackboard, so you do not miss much. But however, the reason that I am doing continually is because we need to leave early to avoid the traffic. Last time when I left, there's no traffic, so I was suspecting, oh, no traffic till 9 o'clock or 9:10. Anybody left last week around that time? We're all lucky, right? One of you, if you want, voluntarily stay a little longer and tell us next time, hey professor, there's no traffic. Then we'll come back to 6:50 to 9. Okay.
Yesterday I left here at 9:10.
No traffic?
There's
There's traffic, right? Getting out of the campus takes, if you encounter that bad situation, within this short path from here to the signal to the Broadway, 30 minutes.
Really?
Yeah, I had that last few years. At the beginning of each semester, I had that problem. So this semester,
because everybody's leaving. Yeah, they all
right.
at the same time.
And then first few weeks, they don't miss, right?
Yeah, and after
After that, they know how to manage it. So sometimes I don't go to school. So, and also professors, first few weeks, they don't start early. So, but I'm doing the reverse. Right. Introduction and tutorial to coding in Python. So if you do not want high pay, you don't need to. If you do not want to be high paid, you don't need to take this module. Introduction and tutorial on coding in Python. Topics, this module is installation, configuration, coding. There are two types of codings in Python, right? User interactive. There's no way that you can say if there's a command line shell terminals. So that if you want to do real coding, then use an editor. Save it first before you execute. Execution, if you are in user interactive, then it executes immediately. Command line execution, then you have to create a file first and then run it. Or using IDE. That's what we are going to do. Python. Okay. So editing and executing together. Installations. Depending upon the platform, Windows, simple, right? You may have a command line Python or Python. We're going to install two things. This course, yeah, we don't do much about, yeah, not really two cases, right? But if you want to have a real good programming environment for Python, then better to have two things. Command line Python, I wanted to download the two versions, 2.7 and 3.6. 3.7 is under construction right now. Python, I don't know the version, but there is a Python. Okay, if you do Python, then I strongly recommend you to download Anaconda rather than Miniconda. Okay. Currently, Anaconda has the version 3.5. So if you install these three, then you have three versions of Python on your laptop: 2.7, 3.5, and 6. So you can run selectively. Mac and Linux also possible, but Mac and Linux for command line already installed. You don't need to redo. 2.7 and 3 dot, depending upon the laptop that you purchase. If you purchased a couple of years ago, then 3.2, 3.4. Recent years, then 3.5. If you purchase next year, then 3.6 or 7. Python also available for Mac or Linux. Configuration, ways of configuration vary. So you have to decide your preference. For example, in in command line, in command line, if you simply say Python, which version is running? Because that is my configuration. Oh, 3.5. Okay, that is running. If I do Python 3.6, Python, what version? 3.5.2, 3.6. This is a beta version. Then I have 2.7, 2.7.13, right? Selectively. So you can, as I said, where's my mouse? Ah, okay. Yeah. So 2.7, 3.6 and 3.5 all can be, I recommend you to download the 3 versions and configure it in appropriate way. So let's download it. You can download from here, this website. I want to download the 2.7 and 3.6 now and install it here in this directory. Do it now. I'm going to show it to you here so that you have Python 3.6 and Python 2.7. Okay? Like this. It takes time, right? 2.7 and 3.6. Raise your hand if you already have those 2 versions. Okay. Those who have that, then come back here, Paizo, and download the Anaconda. When you download and install, it may ask you to whether you want to use it alone individually or anyone in your system, one or the other. You can choose one or the other. It doesn't really matter, right? So anyway, your laptop is your own. There's no other user shares. Then doesn't really matter. But what matters is that the location of the software is not the same. If you install it for yourself only, then it is installed under your directory. If it is installed the entire system, then it is above you. So 2 different things. So later, if you want to do configuration on your Paizo, Paizo understand it. so you don't have to worry about it.
How can you see if you have anaconda?
How can what?
How can you tell if you have anaconda?
If you want to run anaconda only,
Yeah, because I had
oh yeah, you can run it. You have to go to the directory where you installed anaconda. Then there is anaconda. Anaconda is an application, so you can bring up anaconda. Anaconda is not just for Python. It can be other language also, and much more powerful than Paizo itself. For this course only, we don't do much about anaconda. But if you have anaconda, then it has some artificial tools, machine learning tools. We may, right? Much more powerful. But language itself, anaconda is not really needed. Paizo is sufficient. So Dallas is leaving. See you next week. If you can make.
You know, I didn't register.
Hmm?
Because I had this class registered, but I had other requirements. Remember I talked to you last semester about this course?
This
Or,
requirements?
remember for the graduate law you approved? Is this data?
Did I say that? Required what?
No, I was going to be in this course, but I
Oh, you
had to drop.
had some other?
Yeah.
Oh, yeah. That's fine.
Good night.
What's the difference between anaconda and miniconda anyway, you know?
Miniconda is meaning anaconda. It's the name.
This one says anaconda.
Anaconda is the biggest snake. Did you hear it? Better?
Yeah.
Looks like.
It's just OSX, right?
Oh yeah. Yeah.
This is for OSX, isn't it? Or- Yeah, you click on the anaconda site though.
Yeah, it looks like it has the bottom. What was your specialty?
Mechanics.
Oh, army? Or
Yeah, Army.
mechanics.
Yeah, but I was with the military police, so it was a lot more fun.
Mechanics for vehicles or
Yeah,
tank?
nothing too interesting. I was just really with the military police. I was stationed with them, so I got to go through the.
For how many years?
4.
4? Oh, minimum.
Yeah.
Were you active or in it?
No, I'm a veteran now.
You're done?
Yeah.
Oh, I see. Dispatched it to any country?
No, just I stayed in Fort Bragg primarily, down in North Carolina. Yeah, we were supposed to go on deployment, but they canceled it like last minute back in 2016. No, 15.
North Carolina, that's a basic training camp.
No, South Carolina.
Oh, it is South Carolina.
Yeah. Yeah, Fort Jackson is the one for a lot of basic.
My girlfriend's cousin's in like Guantanamo or something. Yeah, she's like, yeah, she does that. But I think she was in military police too as well.
Yeah.
Oh, Guantanamo. There's still prison?
Yeah.
Yeah, she does that. Yeah, that's what she did.
Yeah, Obama never got to actually it's still there.
Right. Done. Done?
We did it for the other class. Thursday night?
Oh, yeah. Okay. Now let's move a little bit. Okay. So you can come back to do some others. Okay, where? Okay. Yeah, as I said here. Yeah, Paizo 4.4.1 and Anaconda 3, so 4.4.0. Anaconda right now 3.6. The one that I had is a 3.5, right? So not necessarily 3.5. Okay. I'm not going to teach you tomorrow. You guys will have similar stuff. Not much about Python, right? This data mining is not programming itself. Programming maybe 20 or 40%. And concept is 70 or 80%. Algorithm concept understanding. The programming includes the tools that I ask you to download so that you can use it, and not programming, but use it. That is part of the lab that we are going to do. So let me tell you. After I explain this, we'll do quick coding. Okay. Although I posted, for example, some examples, but not much here. One thing that you need to understand here, there are three types of data. Three already defined data types in Python. If you are using Java or C language, then this data type should be defined. But Python is the language already provides you primitive data types, which is good. In other words, if you are learning Java, then you have to learn Java maybe 1 semester or 2 semesters. And then you have to take data structures. There you can learn some of those. List, tuple, or dictionary. Dictionaries in C or Java is called hash. Hash. Okay. There's a more common terminologies. Hash table or hash structures. If you have a coding interview, then almost a 30% of chance that you may be asked about hash. Can you implement hash in Java or Python? Python already given, right? There's a dictionary. So in another language, this is hash. Okay. Cryptography uses a lot of hash values, right? Exact same ones. The concept-wise. Tuple and list. They are similar. Tuple and list. Similar. List is like a linked list in Java or C. It's a list. Tuple, there's no tuple in Java or C. Tuple can be implemented in Java and C as a class. So it is not really same as this. So tuple is a very, very simple data sets, like a list. Here is a very, very important question that I want to ask you. Here, number 1 about list, number 2 about tuple. Everybody, take a look at that example. List example, list is in square bracket, open square bracket and close square bracket. If it is a tuple, then parenthesis, open and close parenthesis. If it is a dictionary, then curly brace, open and close curly brace. Dictionary is quite different from list and tuple in a way that if you have a dictionary, then there is key and value pair in between the delimiter colon. Those pairs are delimited by comma. So value colon variable key colon value comma another key colon value comma key colon value comma key colon value. That is the dictionary. Okay, so Now go back to the list and tuple. Question that I want to ask to you is, by looking at that example, can anyone see the difference? List and tuple. They are very, technically they are similar, but real interpretation is not the same. Jess, you still remember that?
Was I just besides the brackets? You're talking about like the
In what case that you use a square bracket? In what case do you use parentheses? Therefore, a list and tuple.
when it's like a consistent list? Does that have to do with it? Like they're all the same, they're part of the same. No.
Oh, well, go good. You make.
Like a list is part of the same thing, and tuple is very separate. Maybe I don't know.
Okay. List. Yeah, you're right. And tuple, can you elaborate a little bit?
Tuple referred to something else.
What about this? All the values in one tuple is describing about one object.
Oh, I see.
Tuple, so if there is a somebody, John, faculty 555, is describing about one object. But list, each one is different objects. A, number 1, number 3, Mercy. Structure-wise, they are not really different, right? Value, comma, value, comma, value, comma, value, comma, same thing. John, comma, faculty, comma, 555, comma, whatever after that. And accessing, very similar. Constructing, very similar. List and tuple. Only your interpretation is different. Dictionary is quite different, right? Key and value pair. See in that example, what kinds of dictionaries described? Country and capital, right? So there is a hash. Given a key, you can get a value. Hash value, hash key, hash table, hash structure. Cryptographies, if you give a key, it returns value. That's dictionary. So dictionary is useful in many cases. So all language has some types of dictionary. I think dictionary is a good term rather than hash. Hash is more computer science terminologies. Dictionary is more English-like terminologies, right? So English dictionary, not frequently used, right? But you still remember dictionary, right? Real dictionary. How long ago have you looked it up?
I know there's children who don't use the dictionary.
Yeah, in your middle school, you use the dictionaries, right? You open up. My son does not know how to use dictionary. Shame. When they want to pull out a cell phone. Dictionary is this. There's an alphabetic. The word, right? Word is a key. And then there's explanation about that word. That is the value. So dictionary is similar. Dictionary can be defined as the following. Dictionary is a series of key and value pairs, right? Key is the word, value, you can say annotation or explanation or meaning, whatever. Acronym or synonym, antonym, whatever. That's a dictionary. So in Python, that symbol is important. When you see the symbol, then you quickly understand, oh, this describing about list. Oh, this guy describing about tuple. If it is a tuple, then you can simply say, oh, all the values in one parenthesis describing about one object. So another tuple, another object. Another tuple, and another object. Tuple is a terminology used in database, right? Anybody took database? The database says tuple. Tuple is nothing but an object. All right. So let me give you an example of my already here. So that's that I need to. Okay. I did 520 Python and logical expression. That's what I did here. So you can run it from your terminal, which say command line terminal, right? So we have cursor blinking. I need to change right now in F drive, so change F, and then change the directory within drive F. Then I have let me give you a demo that I made this afternoon. Yeah, 1:30 today. Inference engine. Let me give you this demo and then we do step by step. Inference engine. Oops. PY. Nope. Cannot find it. Oh, there's not. For There's some error. Okay, bring piezo up. If you install piezo, then there is an icon, so you simply bring that up, right? Okay, this is piezo. Okay. What happens here is that what is this type? Can anyone explain? Data structures that I explained, right? So entire, because we have a square bracket, what is it? List. So list inside, then you have multiple parentheses, right? So you can say that is a list of tuples about where each tuple, if you see there is a two values, right? So this is the rule. Remember the rule? Implication? What happens is that I represent the fact in this way. Listen what I did here. If raining, cloud in the sky. That is the first parenthesis. Second parenthesis. Or if you win today, for example, then you will be a champion. So another rule. If weather is good, go to beach. If cloud in the sky, weather is bad. If go to beach, swim. If swim, you'll be tired. If sunshine, weather is good. If you are champion, you will be excited. If you are excited, you will not be tired. If weather is bad, don't go beach. If no beach, no swim. If no swim, no tired. That type of rules, right? A lot of a series of rules are represented in pattern 1. Pattern 2, another rule sets. If you go to beach, you swim. If you go to beach, there is a wind. If there is a wind, then rip current. If rip current, no swim. Do not swim. So you have 2 sets of rules as we looked. The rules can be expressed in many ways, but the data type that I was using in this example is a list of tuples. So each tuple represents a rule, an implication. Remember that arrow? That is represented in Python like that. And then some of the Python language. Okay, so we are going to learn it, but if I can give you a demo. So P is not defined where? Line 22. It's not P. Y is not. Changed. Okay, so what happens here is that from this engine, given fact is this, sunshine. That is a given fact. Remember that in the slides that we looked at, there's a box, right? Box can be data miner or machine learning box. So that box has an input, fact. Then there is an output, another fact. So what happens here is this. Sunshine, then there is a fact that we learn from there is go to beach. Okay? It's a direct implication. But if you apply all the rules that it inferences, go to beach, there will be wind so that you may swim, there may be rip current, no swim. If you no swim, no tired. If you swim, tired. I know there is some conflict in the consequence, but according to the rule that you may have that type of fact, that is a learning. Okay? So if you have another rule, then you have another thing here. For example, if you add here let's say tired, then say sleep. Okay? So there is another rule. So rule is added. Therefore, you have different consequence. Because of that rule, you have another fact produced. It says sleep. Right? Same thing. If you have here, instead of sunshine, if you say wind, then you have different. Because of wind, you have no swim. What it inferences is that no swim, therefore no tired. That type of consequences. Coding, very simple, right? One definition and another definition. Only two definitions, and we simply run it. So we'll learn that. In order to learn it, we have to do a little bit of programming syntax. We have about 5 minutes. I'll give you 5 minutes to do. Here, we have two types of user interactive mode. You can have a user interactive mode here in command line by typing Python. This is the same as here in Paizo. If you have Paizo, then you have an editor and execution in one application. If you have terminal, then it's not, right? You have to come here. So let me start with the terminal. If you come here, you have to do the following. If you want, many times, oh, I need help, then type help, open and close parentheses. This guy says help only. I say help. If you say help, then it says, oh, you need to have open and close parentheses. Therefore, help, open and close parentheses. Remember that, oh, I didn't say that to you, right? Yeah. Python is kind of a functional language. So language itself in the form of a function. So we have literal, open and close parentheses. That is a typical function. And hit enter, then you will have help, right? Here, modules. So a lot of modules comes with the Python installation. So we'll look at that. If you type modules in help command, because it's an anaconda. If it is anaconda, it's a little different. I need to stop. Control C. What I want to do here is I'm going to execute Python there, help, modules. Then you will see the list of modules that all come together with this installation, Python installation, Python 3.6 installation, not Anaconda. So these are the modules that you may be able to use. Okay, a lot of things with the underscore. Okay, so I'm going to explain that later. And a lot of languages like gzip, hash library, email, CSV, crypto, copy, codex, code, CMD, and here some of math, numbers, numpy. Well, I think numpy is already installed. Something already installed here. Tkinter, right? A lot of GUI programming. XML, RE is a regular expression. So those are the things. If you want to see in more detail about the module here, for example, random, then you simply type random. Then this is help. Random variable generator, the description, hit spacebar, then page by page. So class random. It's a lot of explanation about that. And methods. Random has this kind of method with the double underscore, and also method like choice or exploit, Gauss, whatever that, right? Those are all the method that associated with the module called random. So you may be able to see all of those modules. After this help, if you want to get out, then quit. This is within help. So it's not the language quit, but command quit. So simply quit. But in this Python has a prompt statement triple greater than sign. If we want to get out of this user interactive Python engine, then you need to do language quit. So difference here is if you want to quit from help, then simply quit. Quit from the language itself, then there's a function. quit. If you do quit itself, then it says you have to do the function quit like this. Then you already get out of that. Okay, so back here, if you want to make my list, and then you can say 1, 2, 3, and A, Mercy, NSA, whatever. Yeah, then that is a list. List is constructed. In Python language, you don't need to, like Java or C, type. Then you have to define type and then assign value. All steps are needed, but in Python, if you want construct, simply construct it. So this is a variable, my list. There's no type bound with that, and then values, numeric, character, string, all together can be that. So my list, if you see my list all together, then it returns, oh, there is my list. If you want to see, oh, I want to do first element of my list, then index. This is index. 0 means first element. If you want to do, oh, I want to do last element, then you can say -1. Then there is the last element. If we want to access second element from the beginning, then because it starts from 0, second element is 1. So if you do 1, then second element, number 2 comes. If you want to do last second element, then -2. Then last second element, which is Mercy. If you want to have, or I want to express this, 3 elements from second, third, and fourth, then start from the second element, which is number 1, colon. Zero, 1, 2, 3. 3 is a A, right? Then you need to type 4. Therefore, you have 2, 3, and A. A is, the index to A is 3, right? 0, 1, 2, 3. But I didn't do 3, but number 4, which means if I specify colon, if I specify index using colon, then first index means I want to start from this index. And then second number is the index. I want to go to that index, but exclusively. That number is excluded. So 1 before that index. So all kinds of this we'll continue to learn. This is a module 3 according to our syllabus, but we jumped into the third topic a little early. Okay? So before you encounter messy traffic, I want to stop here. Okay? Any question?